Okay, so this is the first video in the series of this flipped classroom assignment on complex numbers. Now before we get into that, we need to understand why this assignment is important, okay? And it has to do with factoring. As you know right now, for when you do on your factoring flowchart, when you get to binomials and you're deciding whether it's perfect squares or perfect cubes, and then you say, okay, it's perfect squares. And you get down to perfect squares and you say, oh, is it sum or difference? And then you go to sum and you say, oh, it's sum of squares, and then under sum of squares it says it's prime. It means it can't be factored anymore. Well, this lesson is going to change that. There is, in fact, a way to factor sum of squares, and it has to do with complex or imaginary numbers, as they're called. So let's go back a couple steps first. We're going to start with some things that we know and what we need to know about factors versus roots. Okay, so here's what we know. If I ask you to find the roots of y equals x squared minus 9, I see that x squared minus 9 is a binomial, and it's also a difference of perfect squares because there are two terms here that I can take the square root of both of them. So I'm going to go ahead and factor this. This factors into y equals x plus 3 times x minus 3, just like difference of perfect squares factors too. Now, the instructions say to find the roots, not just the factors. So these are the factors. So if I then want to find the roots of this, the roots means x-intercepts, right? So that's when your y value is equal to 0. So I'm going to go ahead and substitute in 0 for y. So now I'm trying to find which values for x is going to give me a 0 for the whole function, which means either this binomial or this binomial has to be equal to 0. So I'm going to set each of these binomials equal to 0, and that's going to give me the roots. So when I solve for x here, I have to subtract 3 from both sides, and that gives me x equals negative 3. And on this one, I need to add 3 to both sides, and that gives me x equals positive 3. So what we see here is that our roots are negative 3 and positive 3. So we would write them as roots, which means you have an x value and your y value is always 0. So we have negative 3, 0, and 3, comma 0. Now this is something we know already, or we should know already, how to factor, and then from factored forms, we set each of the binomials equal to 0 and solve for your roots. So here is what we don't know. If I say, here are the roots, now I want you to find the equation. This is exactly backwards of what we just did. It's the opposite order. Okay, so in this situation, I'm given the roots. Now I want to find the equation. So let me go back for a second. Remember here where we ended up with the roots? Well, these roots came from binomials. And the binomial has x plus 3, and the root is negative 3. So you can see the relationship between the root and the factor is that if you're given a root, then in the factored form, it's just the opposite sign. So here's what that would look like here. If I'm given the root of 3, 0, then a factor of that root would be x minus 3, because it's positive here, so it's negative in the root. And so for this one, the factor would be x plus 3. Well, now that I have both of my factors, I can write this in factored or intercept form, which would be y equals x minus 3 times x plus 3. And that is my equation. So this is kind of the new stuff. This is a little bit of what you need to know to continue on with the flipped classroom. So if you need to rewatch this video, rewind, reset, please do so before you begin the next video.